So we would be solving phosphorus and putting it into elemental Lewis structure, which involves using dots to show how many valence electrons they hold. So with phosphorus, if you look on the periodic table, you can see that phosphorus is in row 5, meaning that it contains 5 valence electrons. In an elemental Lewis structure, that means that it has 5 dots, arranging in a specific order to show how many valence electrons it holds. So to solve for phosphorus, the first thing we will do is, so we have phosphorus here, first thing we will do is see what the order is. So the order for elemental Lewis, it goes clockwise. So you put 1 dot on each side, and that would be 4. But since we have 5 valence electrons, we would have to put 5, so we would have to overlap 1. So this is how you draw it. So you put 1 on the top, then 1 on the right, so we're going clockwise, 1 on the bottom, and 1 on the left, and that's 4. But we need 1 more, and we add this one on the top, and this creates a lone pair. Okay, so our next example is helium. Okay, so now notice that when we look at the periodic table, it has 8 valence electrons, or it has 8, it's in row 8. And this means it qualifies as a noble gas. And noble gases are a little bit different than all the other elements because they're far less reactive, and normally they hold the most valence electrons. But for helium, that's a little bit different. So here's an example. So if we did argon, argon is in the noble gases row, and since it's in row 8, it says 8A, it would hold 8 valence electrons. But helium is a little bit different because helium only has 1 electron shell, and it can only hold 2 more valence electrons until it's full. And now if you look at any other element on the periodic table, so we'll go with sodium. Sodium prefix is Na, and normally you would follow the valence electron. So this is in row 1, so it would only have 1 dot up here at the top. But helium does not follow this rule. Helium's a little bit weird. So it can only hold 2 valence electrons. So you would write it here and here, following the elemental Lewis structure correctly.